Okay, right. So what we're going to look at during this session is climate change. And with that in mind, we need to know, well, how do we know climate change is happening in the first place? I have many fun conversations with my dad, who doesn't believe in climate change or global warming at the moment, so that's interesting. Causes of climate change, both human, or better word, anthropogenic, and physical, which means natural. Okay, it's not just people that are causing this to happen. There are natural causes, and that's my dad's argument. Impacts of climate change in terms of the social, economic, and environmental impacts, and then what are we doing about it? Adaptation versus mitigation. Okay, so just a bit of background really quickly. In a nutshell, my dad has a point. The Earth's climate has changed over the years. Okay, there has been times where the climate's been warmer. We call these interglacial phases. Now, inter comes from the French entre, which means between. So we're really just saying between glacial periods. In other words, between ice ages. Okay, and when it's been colder, we call those the glacial phases. All right, and our last major cold period was called the Pleistocene, which started 2.6 million years ago, and it ended just 10,000 years ago, which sounds like a long time, but that is not long at all. We're currently in a warming phase called the Holocene, and these are both part of what we call the Quaternary period of Earth's history. And I'm moving my face around too much, let's put it there. And if you look at this graph, this kind of shows you a bit of the world's history here. You can clearly see that the world's temperature is fluctuating from those interglacial warmer periods to the glacial colder periods as well. So my dad does have a point. However, when you look at more recent graphs, you can clearly see that we are increasing this as humans. Okay, we have sped up the rate of warming. So global average temperature is massively increasing since the Industrial Revolution. Okay, and there's just two different graphs to back that up there. Okay, so how do we know? How do we know this? What do I say when I'm arguing with my dad? We have recent evidence and we have proxy evidence, which means historical natural data. So the top three are the recent ones. First of all, if you just look at a thermometer record over the last 100 years, you can clearly see that temperatures are increasing. If you look at old photos of glaciers and current glaciers, they're definitely shrinking, so that proves the world is warming. And sea level rise. Sea levels are rising. That's happening because ice is melting. Okay. More cleverly, the historical proxy data is unbelievable. So you've got these ice cores down here where people go to Antarctica and Greenland and places like that, and they take these ice cores, which can be 10, 20, 30 meters long, and they tell a story from thousands of years back. For example, if there's some gas bubbles in there like carbon dioxide or methane, that might suggest, or it does suggest, that that was a warmer period of time. Same for ocean sediments. Again, go deep down into the seabed. If you find evidence of fossils, for example, or sort of sediments, okay, that have come from warmer periods, but you're in a cold place, that proves that once upon a time that was a bit warmer. And tree rings. I quite often go to the woods with the kids, look at a tree stump, and that tells you a lot, okay? And it is true, how wide the tree is usually gives you an indication how many rings there are, how old it is. But if there's a wide ring, it might prove that there was a rainy season, so the tree was able to grow more. There might be a scar, okay, in the tree, which represents there's been a forest fire, so that might have been a hot, dry season. So we can tell a lot from this proxy evidence as well. So climate change is real and is happening. This is the greenhouse effect. You need to be aware that this is happening. It happens naturally. If it didn't, our planet would be freezing cold. So the sun's rays get trapped in a natural layer of greenhouse gases. Think of a greenhouse, you go into it, it's really hot because it's trapping the sun's rays. However, we are enhancing this greenhouse effect. I think of it as a blanket around the Earth, okay? Students sometimes write that in their exams, which they shouldn't. Just put a layer of gases, okay, around the atmosphere, around the Earth, called the atmosphere. And we've got carbon dioxide, we've got methane, we've got nitrous oxides in there, trapping the sun's heat, heating up the globe. This is global warming. This is the enhanced greenhouse effect. This is where we are now, and humans are absolutely causing that, okay? So, how are we doing that? Well, students need to know that there are human causes, anthropogenic, or physical natural causes. So we have burning of fossil fuels as our first human cause. For coal, oil, and gas for our power generation, we're burning fossil fuels, and that's releasing huge amounts of carbon dioxide into the atmosphere. We also cut down our trees. We call that deforestation. In doing so, trees act as a carbon sink. Okay, they absorb so much carbon dioxide. When you cut them down, all that carbon is released into the atmosphere. And what do they use to do it? Machinery, which again burns fossil fuels and releases more gases. Okay, so really, really bad news. Farming, agriculture, better word. Let's upgrade that word straight away. Agriculture. First of all, to make farmland, you might cut down huge swathes of forest. If you look at the English countryside, any flat grasslands you see, they're generally not natural. That used to be forest or woodland. It's now been turned into farmland. Okay, so again, releasing carbon dioxide. And also our huge demand for beef. Cattle release methane, which is 20 times worse than carbon dioxide at enhancing the greenhouse effect. So our demand for beef is enhancing that greenhouse effect. Okay, thousands upon thousands of cows in places like Argentina, cutting down the rainforest so they literally can graze there for our consumption. Okay. But there are some natural causes as well. For example, volcanoes, volcanic activity. Now, two ways they affect the Earth's climate. They are warming it up because they release carbon, okay, when they erupt. And again, just like a power station, that enhances the greenhouse effect by trapping heat. However, they also release sulfur dioxide. And sulfur dioxide actually reflects the sun's energy. So think of it as that ash layer here is like a mirror. So the sun's rays hit that mirror and bounce back off. So it can actually cool down the climate. And this has coincided with ice ages in the past when Mount Pinatubo has erupted, for example. We've had some global cooling and there's been wide-scale famine, which is large-scale hunger because crops haven't been able to grow. So volcanoes can have a massive impact. We also have solar activity. The sun is extremely powerful. It's 3,000 degrees burning ball of hydrogen and helium. It releases solar flares now and again, which can actually cause intense energy and heat up our planet. And we also have sunspots, which are just cooler patches on the sun, and they can cool down our climate as well. So again, previous ice ages have coincided with high sunspot activity. And finally, we have orbital changes. Now, the Earth's orbit around the sun usually looks like this. And over 365 days, this explains our seasons. When we're further away from the sun, it's like winter, and when we're closer, it's summer and spring. However, every 100,000 years, the orbit changes shape. Okay, and then you can see when it's all the way over here, it's going to be much colder. But when it's over here, it's much closer. We call these Milankovitch cycles, and that's definitely going to make your students stand out if they can remember that. Every 100,000 years, okay, it changes shape. Then we've got the causes we've talked about, just being aware of which goes into which. And here's some example questions. We have AQA. Explain how the increasing use of fossil fuels and changes in agriculture may have contributed to global changes in temperature. So 2 marks for each one. Burning fossil fuels enhances the greenhouse effect, carbon dioxide, making the earth warmer. And agriculture, same. You could talk about the deforestation to make room. You could talk about the methane that's being released thanks to the cows farting. But don't write cows farting in your exam. LXLB, nice little 2 marker there. Explain one natural cause. So you could choose, orbital changes, volcanic activity, or solar activity, and just explain one for 2 marks. Explain words like therefore, this leads to, as a result of this. You need to get those connectives in. Okay. Impacts. Why do we care? This is what's going to happen in the UK. So properties at risk from flooding. Students need to analyse graphs and data like this. Okay. So our sort of dark reds in the southwest here can be anywhere up to 10 to 20,000 properties at risk from sea level rise by 2050. So that's pretty damn significant. Where do you live in the UK? Is this going to affect you? I live down here in Poole. Not clear to see on this map, but definitely parts of Poole are below 5 metres above sea level, so we're screwed. Droughts and floods are going to become more likely. Already the last couple of years we've had some extreme flash flooding going on. I'm sure you've noticed more intense rainfall. If we are having hotter, drier summers, that's going to lead to hosepipe bans and pressure on water supplies and droughts. And industry might be impacted by, like, the Scottish ski resorts. There might also be positives, people won't be going on holiday abroad because they'll be happy staying here. We call that domestic tourism. And also things like vineyards are opening up all the time, okay, especially in the southwest, Cornwall, Devon, Dorset. Students should be able to categorise these into social, economic, and environmental, and maybe have an idea of, again, what do they think is the most significant impact. All of this stuff, guys, is evaluation, big AO3 marks. How's it going to affect the world? Sea level rise will affect up to 80 million people. We talked earlier about tropical storms increasing in magnitude and strength, so that's bad news. Different species are going to be affected. If Arctic ice is melting, polar bears, for example, can't use that ice to hunt from. And malaria is carried through mosquitoes, and mosquitoes thrive in hot tropical climates. So if hot weather is spreading away from the tropics, mosquitoes are already going further afield, and therefore malaria, unfortunately, is going to affect up to 280 million extra people. Okay, not good. And then finally, what we're doing about it. This can be split into mitigation, which means management. So think mitigation management. How can we stop the problem? How can we reduce it? And adaptation is, okay, I accept that climate change is happening. What can we do about it in terms of adapting so that we can still survive and get along? Okay, so what we're doing to mitigate, we are using renewable energy like solar panels, okay, and wind turbines. And we're also using carbon capture and storage, where we're trying to get the carbon before it goes into the atmosphere and actually trying to suck in some of that carbon that's already out there as well. We then pump it underground and store it underground, okay? That's in terms of mitigation. And also international agreements like the Paris Agreement, which aims at limiting global warming by 1.5 to 2 degrees. Okay, some projections are up to 4 to 5 degrees, which is just terrifying. A world that's even 2 degrees warmer is going to be quite a scary place for a lot of people. So if we can't slow it down much, what can we do to adapt? Here's just a couple of ideas. We can plant more drought-resistant crops, okay, which are able to survive in those hot, dry conditions, so we can reduce famine. And simple things like building houses on stilts to deal with sea level rise. Okay, and again, finally, just an example question. There's an example there of a carbon capture and storage plant. AQA 9 marker plus 3 SPAG marks. That's as big as it gets in AQA. Managing climate change involves both reducing the causes, in brackets mitigation, and responding to change, adaptation. Do you agree? Explain your answer. Use figure 6 and your own understanding. So again, we're going to tear this question apart at the start. We're not going to go straight in and start answering. We're going to plan it. We're going to bug it. We're going to box the command word, which is explain. We're going to underline all these little focus parts like mitigation, adaptation, okay, figure 6. And we're going to glance at the mark scheme to show that we know it's 9 marks, which means we should be writing 3 paragraphs. If you're a different example, it might be an 8 marker, but it's going to be very, very similar, okay? And just making sure we use good key terminology throughout to get those SPAG marks. We spell them right, and we show 3 clear paragraphs. If I can't see 3 clear paragraphs, you haven't answered this question properly. So how do we structure them? 1 paragraph probably on mitigation and 1 on adaptation. And then a conclusion. What do we think is better and why? Okay. And we've got to use the figure. So what can I see in this picture? I can see carbon capture. So I have to talk about that as one of my mitigation techniques. And just to show you what the examiner is looking for, level 3, which just means 7 to 9 marks, or 7 to 8 if you're a different example. Responses will be developed, so lots of connectives, therefore this means that. You've got to use figure 6, okay, so you have to talk about that photo, and you've got to do some kind of evaluation. What do you think is the best? And here's an example of some evaluation to finish off. Let's just move this out of the way. He says, I'm having issues with this guy. Let's try again. No, brilliant. Oh, there we go. Okay. Mitigation addresses the root causes by reducing greenhouse gas emissions, while adaptation seeks to lower the risks posed by the consequences of climate change. Both approaches will be necessary because even if emissions are dramatically decreased in the next 20 to 30 years, adaptation will still be needed to deal with the global changes that have already started. So they're talking about time, they're talking about global, okay? So lots of kind of AO3 themes there to get those evaluation marks. And they're just saying that actually we need a combination of the two. Okay, hopefully that's been of help. The final 2 sessions are going to be linked to biomes, ecosystems, and rainforest and deforestation.